Yesterday we started this problem about the polling consultant and the environmental problems, and I also believe we got through PAN, and we didn't do I or C. Okay, first thing I forgot to say is you guys need a set of tables. So take out the green set of tables that I gave you, the cardstock ones. If you don't have that, come grab a set of the plastic tables up here. Okay.
Could you grab me one too, please? For sure. Thank you.
Do you guys have these green set of tables somewhere? Because you recognize you need them for the homework, right?
Yeah, I got one.
Okay, awesome. For the next, well, at least for all panics, you need this table. There's not a way that I'm going to show you to do it on the calculator, so you definitely have to have these tables. So, for those people who were not here yesterday, and just to review for all of us, yesterday we did P. That's where you define the parameters, so let pi be the population proportion, blah, blah, blah. A was the assumptions. First assumption is always the same for a panic. First assumption is that you have a random sample. Second assumption is that your sample is large. Third assumption is that your sample is small relative to the population, so 10% rule. Then we did N. N was the confidence level, so 90%. Give me the name for the confidence interval. So proportion is called a large sample confidence interval for proportion. And then we talked about the table. So I'm going to use the T critical values table. Oh, I said that, right? Yesterday that we're going to use the T critical values table, and I'll explain what that is, but then I never did. Yeah. Okay. Awesome. So now we're doing I. Those people who were here yesterday, you might want to leave that whole side blank and start your I over here. But I write really big, so I need the whole space. Okay, first thing you need to show me is the formula for a confidence interval. The formula is P plus or minus Z times the square root of P times 1 minus P all over N. Does any of that look familiar? If I'm asking you, it probably should.
Yeah.
So, what part looks familiar?
The P minus B 1 minus.
Yeah, that should all look familiar. What is that? Standard deviation of?
Proportion.
Population.
Okay, you guys are just saying random words, so I can't tell if you're right or not, so I'm just going to tell you. It's the standard deviation of the sampling distribution for proportion. Okay, so you need to show me that. Then you need to actually plug in numbers. So RP is 28%, so 0.28. So I'm going to get 0.28 plus or minus, leave the Z blank right now, and I'll show you how to look that up, times the square root of 0.28, 1 minus 0.28, all over 500. Okay, that Z value you're going to find on the table. I told you yesterday you're using the T critical values table, so find that table right now. On here it actually says T distribution critical values. It should be table B. We have that? Table B? Okay, here's what you're going to do. At the very bottom, it says confidence level. So you're going to look at the very bottom. You're going to find that 90% confidence level. And then you use the number right above. So 1.645. So the way this table works is Z comes from the standard normal distribution. So Z is the normal distribution. T is a completely different distribution. If you look at the very bottom line of this table, though, of the T table, those are all Z values. So that's why you use the T table, as the bottom line is all Z values. So now we're going to plug this in. I'm sure you guys know how to plug this into your calculator, but I would like to show you a more efficient way than what you're probably going to do. So I want you to plug in the lower bound. So do 0.28 minus 1.645 times the square root. Do everything all at once and do the subtraction. You don't need like any special parentheses. You should get 0.247. Do we? Okay. Now in order to find the upper bound, don't retype all of that. That's way too much work. Hit second enter, and it should bring all that back again. Did it? And now just go up and change the subtraction to addition. And then you should get 0.313. You don't have to do it that way, but it's a lot faster than plugging them both in separately. Okay, I'm seeing like looks of confusion, so did I lose us somewhere?
Yeah.
Yes, where did I lose us?
No.
Okay. Are you guys good?
Yes.
Okay, so this is your confidence interval. Now you need to write the conclusion. So for this confidence interval, we looked for the proportion of people who listed environmental problems as the most important issue. This interval tells us we think that that proportion is between these two values. It's not a guarantee, this is just what we think. In the conclusion, you need two interpretations. You need to interpret the interval itself, and you need to interpret the confidence level. These are pretty much sentences that are always going to be the same, so I would highly suggest that you memorize them. All that's going to change is the context. So you start with, I am 90% confident. Okay, 90% because it's a 90% interval, so if I change that number, you're going to change from 90 to 95, etc. I'm 90% confident that the population proportion of people listing environmental problems population proportion of people listing environmental problems as the most important issue is between 0.247 and 0.313. So all you're saying is I think pi is in that interval. It is not a guarantee. That interval is based solely on your sample. So if you happen to take a sample that was not representative of the population, then pi is not actually going to fall on that interval. So we think pi is between those two values. We don't know where though, and it could be anywhere between the two or not even in the interval. So that is interpreting the interval itself. That one I think is easier. The one that is harder to interpret is the confidence level. So what I mean by that is, what does the 90% mean? This is the second sentence that you need to memorize. Don't put your own spin on it. Memorize it exactly the way that I say it, okay? 90% confidence means in the long run, in repeated samplings of size 500, approximately 90% of similarly constructed intervals will contain the population proportion of people listing environmental problems as the most important issue. Okay, here's what that means. Do we recognize that our interval is going to change based on the sample that we take? Right, so each sample is going to give us a slightly different interval based on p. So this is saying if I took every single sample, or I took 1,000 samples, let's say, and I constructed a confidence interval for all 1,000 samples, 90% of them will contain pi, or about 90% will contain pi. The other 10% are not going to contain pi. So we don't know whether or not pi is in this interval. It could be part of the 90% that contain pi, or it could be part of the 10% that don't contain pi. Does that make sense? You guys are just staring at me. Give me some feedback. Yes, it makes sense, or no, I have no idea what you're saying.
Yeah.
Yes, so if I did it a whole bunch of times, constructed all the intervals in the exact same manner, 90% of them are going to contain pi. And that's based on the way that we construct the interval. That's assuming that you have good samples too. So that is a panic problem. What do we think? This is the shorter of the two types of problems you're going to do this semester. So, do we have any questions on this before I erase it? No. Okay, good.
The AP test, they're not going to grade grammar, right? Like at all, like.
They do not grade grammar.
Okay.
But it is shocking to me how poor your grammar is. Not you individually, but you as a whole. You guys have bad grammar, bad punctuation. The spelling sometimes just makes me so laugh. No, because when I use like the word in the problem and then you misspell it,
That's me.
that wasn't you. No, I did
No,
not
but I
say
do it a
that.
lot.
Okay, go to the previous page. So page 11. Okay. Well, actually, let's look at the top before we go on. Here are some of the things that you need to understand. Okay. One thing. This right here, the square root, is called the standard error. Okay? So the square root is called the standard error. Everything after the plus or minus is called the bound. So this part's the standard error. As soon as you include z, that's called the bound. You might be asked, how are confidence intervals going to behave? So how does a 95% confidence interval compare to a 90% interval? Let's think about this. If I go from 90% to 95%, if I'm more confident, what has to happen to the interval to account for the fact that I'm more confident? I go from 90 to 95. I am more confident.
Increase.
What do you mean by increase?
In the long run, approximately.
I don't need a fancy sentence. Like, what does the word increased mean? Like, what do you mean by that? So, for example, if I have two confidence intervals, one, okay, just listen since I can't use the pen. Whoa, there we go. Okay, so one is 0.1 to 0.2, and then one is 0.1 to 0.3. Which one's 90% and which one is 95%? Top one, 90 or 95? If you're more confident, the interval should get wider, right, to account for the fact that you're more confident. So this is going to be a 95% confidence interval. This one's going to be 90%. As soon as I become more confident, the interval has to get wider. If you can't remember that, if you look on your table, look at all these values at the bottom. As you become more confident, all of the z values get bigger. So higher confidence means that your interval is going to get wider. Does that make sense? Okay. Next thing, I'm going to ask you to calculate sample sizes. So not necessarily doing a full panic. So this is the type of problem. In an election, both candidates expect to get about 40% of the vote. What sample size is needed to achieve a 3% margin of error? Margin of error and bound are the same thing. So that's saying that this part, the z times the square root of p, 1 minus p all over n, I want a 3% margin of error, so I want that to be less than or equal to 0.03. So it says each candidate expects to get about 40% of the vote, so that's your P. So here, this is going to be 0.4 times 0.6. I don't know what N is, that's what I'm solving for. We were not given a confidence level. What did I tell you if you were not given a confidence level? Use 95. Okay, so look on your table, find the Z value that corresponds to 95. What is it? 1.96. Okay, I would like you right now to solve this inequality for N. I have an answer, so when you have one, show me. Exactly how I want it. If you're not sure, talk to your partner. Good? Is that the final answer that you got? If you should have gotten a decimal. So did you get the decimal and you rounded it up? Beautiful. Okay, this is what you should have gotten. N has to be at least 1024.43. Okay, you have to pay attention to where N ends up on the side of the inequality. So previously it was on the less than side, now it's on the greater than side. Remember how every time that we did mean, standard deviation, all that, I told you never, ever, ever round? Right? So like if you calculate the mean number of children that somebody has and you get 1.5, I told you don't round that. This is the only case where you round. You have to show that decimal and then you have to round it up. Always round up because it has to be at least that number. So you would say N is 1,025. That is the sample size that is needed. I cannot stress enough that you have to show the decimal and you have to round up. On the AP test, if you don't round up, so you just left your answer as 1024.43, you automatically lose an entire point on the question. So like the whole question's graded out of 4, you're automatically down to a 3 because you didn't round up. That is something silly to lose points for, so don't lose points for that. Now, instead of asking the question like that, I could ask it like question 2. After the election, the winning candidate has no idea what percent of the people support a new tax and plans to survey the constituents. What sample size is needed to guarantee a 3% margin of error using 99% confidence? How does this one change? How is this different than before, besides the fact that it's 99%, not 95? What? Somebody said it.
You don't know the percentage of people that support and are against it.
I don't know P, right? So anytime that you don't know P, you want to overestimate rather than underestimate. So you're still going to use this same formula. And that's going to be less than or equal to 0.03. Okay, what value of P is going to maximize this? What?
0.5.
0.5. So if you don't know P, you use 0.5. Z for 99% is 2.576. So you get 2.576. Then you do 0.5. Okay, just for fun, calculate that again, please. Iowa 1,844. Questions? No? Okay, we have two more things to talk about before you guys are going to do an example. Can I erase this? Yes? Okay. Looking at this interpretation at the bottom of page 11. It says, before the 1976 presidential election, which was Ford versus Carter, a poll predicted 51% for Carter with a reported margin of error of 2%. A news reporter asked a polling expert, what is the probability that over half of the voters prefer Carter? Okay, so this is what it's saying. It's saying that we got a p-value of 51%, so a 0.5, and then a margin of error of 2%. That means that our interval is 0.51 plus or minus that 2%. So we believe that the proportion of people who are voting for Carter is between 0.49 and 0.53. Okay, so the proportion of people who are going to vote for Carter, we believe, is anywhere between those two numbers. We have no idea where. So when it says, what is the probability that over half of the voters prefer Carter? Is it possible that over half prefer Carter? Is it possible that less than half prefer Carter?
Yes. Yeah.
So we can't answer this question at all. So here's what we're going to write. While it is possible that over half of the voters prefer Carter, it is also possible, or it is also equally possible, bless you, that less than half prefer Carter. Okay, generally the question will be asked something like, is it reasonable that Carter will get 55% of the vote? So if I ask you that question, is it reasonable that Carter is going to get 55% of the votes? And you would say?
Yes.
55%. You're going to say no because it's not in the interval. I might ask you, is it possible that Carter gets half of the votes? You will say, yeah, it's possible. It's not a guarantee, though. It's possible, but I can't say for sure that that's going to happen. How are we feeling about this stuff? Not too hot?
That's not too bad.
Not too bad, okay. Okay, last thing. Would we like to know how to do this on the calculator just to make our lives a tiny bit easier? Okay, here's the thing with the calculator. It is only to check your answer. You must do everything by hand and then check it on the calculator. I'm only going to show you the calculator if that's an understanding with us. Yes? Take out your calculator then. We're doing this problem on page 12. So it says the same congressman who did the poll about the environmental problems, he receives, or she receives, oh, no, not that one. The 18th century one. In the 18th century, the French naturalist Count Buffon, counted 2,048 heads and 4,040 flips of a coin. Can he be confident that the proportion of heads is not 0.5? So you're going to hit stat. You're going to go over to tests. The test that you are choosing is one proportion z interval. That should make sense. It's one proportion and it's an interval. Okay, your x value is the number of successes, so 2,048 heads, out of 40 flips, so that's n. C level is your confidence level. It doesn't say, so choose 0.95, and then hit enter, or hit calculate. And that's the interval that you should get. Do we? Okay, so the question originally posed is, can he be confident that the proportion of heads is not 0.5? Can he be confident?
Yeah. No.
No. Why not? 0.5 is in the interval. Yeah. The proportion of heads being 0.5 is possible based on our interval, or is reasonable based on our interval. Give me an interval where he could be confident that the proportion of heads is not 0.5. So make up an interval, is what I'm saying. 0.51 comma 0.52. Yep. He can be confident that the proportion is not 0.5 because it's not in the interval. If I have an interval that's 0.51 comma 0.52, is it still possible that the proportion of heads is 0.5? So is it possible that the value falls outside of the interval? Yeah, it's going to happen a small percentage of the time. In the case of 95%, what percentage of the time is it going to happen? 5%. Yeah, 5% of the time the value won't actually be in the interval. Okay. One note on this, in order to use this, you have to have the number of successes. So like the question above, where I told you 28% of 500, you can't plug in 28% here. You would have to do 28% of 500, and that's what you put in for x. If that number happens to be a decimal, you can't use this. You understand what I mean by that? Okay. Like I said, only to check your answer, I want you to do it by hand instead. Do we have any questions?